Welcome to Periodic Table Trends and Coulomb's Law by Liam George.
More is behind the screen, and Iker, me.
The ancient one.
Wait, can we
Next slide.
How was it?
Atomic structure and Bohr model.
Atoms contain protons, neutrons, electrons. Protons are positively charged and reside in a nucleus. Neutrons are neutral and reside in the nucleus as well. Electrons, they're negative and they orbit the nucleus. Right. Isotopes. Isotopes are basically like subspecies of a different atoms. Like they could have different amount of neutrons or electrons. The average atomic mass is basically all the isotopes. They get averaged out, and that's the mass. Electron shielding. Electron shielding is the reduction of attraction between the outer electrons and the nucleus. This is a major factor in bond strength. Atomic radius is the total distance from an atom's nucleus to the outermost orbital of electrons. It generally decreases as you move across a period from left to right and increases as you move down in a group top to bottom. Electron affinity. The electron affinity is a measure of the attraction between the incoming electrons and the nucleus. The stronger attraction, the more energy is released. It increases across the period from left to right and decreases down the group on the periodic table.
Electronegativity. Electronegativity is the tendency of atoms attracting electrons in other molecules/atoms. The more electronegative atoms are found in the top right of the periodic table, and the lesser on the bottom left. Electronegativity's trend is the direct opposite of atomic radiuses. This ties into acids, as the more electronegative, the stronger the acid it will create. There being a few exceptions, of course. Ionization energy. Ionization energy is the energy that is required to remove an electron from an atom. It increases left to right on the periodic table. It also increases from bottom to top. The higher the ionization energy, the harder it is to pull an electron off an atom. When an electron is pulled off from an atom, it creates an ion. Coulomb's law. The equation for Coulomb's law is F equals KQ1 Q2 divided by D2. Coulomb's law explains the force between two stationary objects based off of their charges. This can also be used to predict the amount of energy that is needed to remove an electron from an atom. Now for the practice problems. First one says, where on the periodic table would electronegativity be the highest? If we refer back to our electronegativity slide, we can see that on the top right, it would be the highest. Second question, would oxygen have a larger atomic radius or a small one? If we refer back to our atomic radius slide, we see that it increases bottom and left. So oxygen, being all the way on the top, would have a very small one. And for our last question, where on the periodic table would electron affinity be the lowest it can? If we refer back to the electron affinity slide, we can see that it increases to top right. So where it would be the less would be the bottom left of the periodic table.
The medium AP questions. Which acid is stronger? Hint. Look for the most largest electronegative atom. So we're given 4 acids right here. We got HCl, HF, HBr, and HI. All of these, or most of these, are strong acids. But we're looking for the most electronegative atom. So that leads us to either HCl or HF. You may think it's HF, but we're looking for also the largest. And since HF is most electronegative, but chlorine is slightly larger, the chlorine being slightly larger will allow it to give off or release that hydrogen way easier than HF because HF is so electronegative that it doesn't want to let go of that hydrogen. It just wants the electron and it wants hydrogen. So that's what makes HF actually the weaker acid, and it's actually a weak acid. So the correct answer is HCl or A. Two spheres have a charge of negative 0.0025 coulombs and are separated by a distance of 8 meters. What is the electrical force between them? So we're given an equation and the Coulomb's constant, since I can't really remember it. So we're given the charge of both of the spheres, which they're both the same. Since they're both the same, it's basically just Q1 times Q2, which is just both of the charges are just squared. You just square one of the charges and you're given the answer. You multiply that by the Coulomb's constant, and you divide the whole equation by 8 meters squared. Eventually, once you do that whole entire equation, the amount of force you'll get from the two spheres will be A, or 879 newtons. What is the average atomic mass, and what is the possible element shown on the graph? This will use the equation where you get the equation F1, or the fraction or the abundance percentage of one of the isotopes times the mass of the isotope plus the percent of the other second isotope, and it just goes on for more and more. Eventually, once you plug in all those numbers for each of the given isotopes, you'll end up with, I believe, around a 91.3, which is the atomic average atomic mass, which then leads us to look on the periodic table to find that the element given is zirconium. AP question 1. For the element X represented above, which of the following is most likely an explanation for the large difference between the second and third ionization energies? Well, as you can see with the equations above, you can see that for the second ionization, it's 1450 kilojoules per mole, whereas the third ionization energy is 7,730, which is a massive increase. So let's go over the answers and use deductive reasoning to figure out the answer. The effective nuclear charge decreases with successive ionization. This is false because when you remove electrons from the outside, that increases the electrons from getting attracted to the nucleus. B. The shielding of the outer electrons increase with successive ionization. The outer electrons are getting removed, so nope. The second electron removed, or C, this electron removed during the third ionization is on average much closer to the nucleus than the first two. Yep, that sounds correct. Now let's go on to D. D, the ionic radius increases with successive ionization. This is false. This is almost the same reasoning as A, where when you remove stuff on the outside, then the electrons are getting closer because there's more forces being applied to them than the other stuff. So that just leaves C. The electron removed during the third ionization is on average much closer to the nuclei on the first two electrons removed. This is because the first ionization is usually the outer or the valence electron, whereas the third ionization is usually the closest ring or the closest electron to the nucleus, so it's going to experience the most nuclear forces upon the electron. AP question 2! Which of the following correctly compares the periodic properties of two elements and provides an accurate explanation for the difference? Let's do the same reasoning as last question to figure out the answer. A. The first ionization of aluminum is greater than the ionization of boron because aluminum has a larger nuclear charge than boron does. This is false because boron is actually a smaller atom than aluminum, so therefore typically smaller atoms have stronger nuclear forces because they're pulling in those electrons to make them smaller. This is why fluorine and chlorine, they're way smaller because they're so electronegative, they just pull in those electrons, reducing the radius. So A is false. B, the first ionization energy of F is greater than that of oxygen because oxygen has a greater electronegativity than F. This is false because fluorine is the most electronegative element on the periodic table. Oxygen is up there, it's probably within the top 5, but fluorine is number 1 for electronegativity. So B is false. C, the atomic radius of Ca is larger than that of magnesium because the valence electron in magnesium experience more shielding than that of valence electrons in calcium do. This is false because if you look at the electron configuration, magnesium is in a higher bracket where it only goes up to S3, whereas calcium has to go through both S3, P3, along with it goes into S4. So you have a whole entire 2 new electron rings around it. So therefore, calcium actually has a larger, or calcium experiences more electron shielding. That leaves us with D. The atomic radius of chlorine is smaller than S because Cl has a larger nuclear charge than silicon does. This is true because chlorine, being one of the most electronegative elements, pulls in those electrons, making its atomic radius smaller compared to S, where silicone is less electronegative, so it's gonna be a little bit more easier on the electrons and pulling them in, so it's gonna be wider or have a larger atomic nucleus. So that leaves us with D is the correct answer for AP question 2. Here's the super mega AP question, or AP question 3. Use the principles of the atomic structure and or the bonding to explain each of the following. In each part, your answer must include a reference or both to both substances. For A, the atomic radius of Li is larger than Be. This is because we're following the periodic trends, and typically the bottom left, or the more left and the more farther down atoms are, the larger their atomic radius is. And since lithium is located 1 row farther to the left than Be is, that means that Li is going to have a larger atomic radius. For B, the second ionization energy of K is greater than the second ionization energy of Ca. This is because when the second ionization energy of calcium, you're still in that S4 orbit of the atom, so it's not going to cost as much because it's still in that valence electron orbit. But for the second ionization energy of K, you're going up all the way to a P3 orbit, which means it's going to cost more because it's not only closer to the nucleus, so therefore more nuclear charge. It is going to just generally be harder to get electrons out of your closer orbits of your atom. For C, the carbon-to-carbon bond energy in C2H4 is greater than what it is in C2H6. This is because C2H4, both carbon-to-carbon bond, has a double bond compared to C2H6 where it has a single bond. The reason why C2H4 has a double bond is because the hydrogens aren't taking up those extra electrons to bond with, whereas in C2H6 the extra 2 hydrogens are taking up those extra 2 electrons that you typically in the other element or other molecule they would use to bond to each other. For the second part of the this problem, we'll be dealing with radioactive decay and half-lives, where Rb83 undergoes radioactive decay into gaseous Kr83. This leaves a solid sample, and over time, how will the average atomic mass of the remaining sample compare to the value calculated in part Ci? Overall, the average atomic mass will increase because of because as RB83 decreases, this will increase the average isotopic mass between the three samples. This is because RB83 is the lowest, has the lowest mass of any of the three isotopes we're given. So when it disappears, that's eliminating the outlier, which will shift the average atomic mass to the higher numbers, or 84.91 and RB85 and RB87. That's it.